2. Okay. Based on the periodic trends and the data in the table, which of the following are the most probable values of the atomic radius and the first ionization energy for potassium? First thing at this problem, you'll have to know what atomic radius is, what ionization energy is, and what are the periodic trends. Atomic radius is half the measurement of the distance between atoms in a chemical compound. Ionization energy is the energy required to remove an electron from a gaseous atom or ion. And periodic trends are, as you go down a group, the atomic radii gets bigger, and as you go right across a period, the atomic radii gets smaller. Initially looking at calcium and potassium, we can see that they are both in the fourth period with 4 energy levels. Continuing looking at potassium and calcium, you can see that calcium has a nuclear charge of 20, while potassium only has a nuclear charge of 19. Looking at the data, it tells us that calcium has an atomic radius of 194 picometers and a first ionization energy of 590 kilojoules per mole. Looking back at the nuclear charge, because potassium has a larger nuclear charge, its nucleus isn't able to pull the electrons in as tightly. This tells us that the potassium must have an atomic radius larger than calcium. Eliminating answers C and D. Now that we've found that the atomic radius has to be smaller, we can look at the ionization energy. Again, looking back at nuclear charge, since potassium has a weaker nuclear charge due to less protons, its nucleus cannot hold onto the valence electrons as strongly as calcium with its 20 protons. Therefore, potassium wouldn't require as much energy to remove the electron, meaning that the first ionization energy has to be less than calcium's first ionization energy. Eliminating answers A, leaving B as the answer.